Hey everybody, welcome back to another fun and exciting pre-calculus class. Today we're going to be in lesson 8.5, vectors. This is on page 171. Now I am going to assume, I know that can be bad, but I am going to assume that you've probably already had this in physics class, okay? Maybe you have, maybe you haven't. And I'm going to trust that your physics teacher knows what they're talking about and they taught you all about this. So here's Mr. Steve just going to review this and you're going to have no problem, okay? That's me assuming, okay? But I'll go through it and I'll show it to you. But again, I'm hoping that this is just kind of review for you at this point. So jump over to your book. We are on page 171 talking about vectors. What is a vector? Well, a vector is really kind of like a specified direction that something is going with a magnitude or with a speed, with a weight, okay, like with a measurement with it. So it's a direction and a measurement with it. So like the speed a car is driving, the rate at which something is falling, the amount of downward force, gravity, all these other things. This creates a vector. So it's a direction with some sort of a force behind it. Okay. Now the quantity that involves only a magnitude is called a scalar. For example, what we've been talking about so far are scalars. And it gives you examples: 20 liters, 50 grams, 15 seconds. How about this? 10 feet. All right, 10 feet is just a scalar. It's not a vector because it doesn't have any direction to it or any speed. Okay. But now once we put them with a specified direction and the magnitude together, for example, a car traveling 950 miles per hour. Now that would be awesome, right? Now that's probably a plane flying that fast. 950 miles per hour west, or a downward force of 20 pounds. Okay, so something dropping that has 20 pounds of force, something like that. These are called vectors. Okay. Now, vectors are often specified with bold letters or written with an arrow or a line. So V for vector, or vector V with a line over top, or V with an arrow on top of it, or you could call that array if you're talking geometry. And you could have just V with just a line over top of it. Okay, those are ways to just say that is a vector. So if you ever see that, then you should think vector. You should think, okay, this is something traveling in a direction with some sort of a force behind it. To specify only magnitude of vectors, use absolute value symbols. So in other words, if it doesn't matter which direction it's going, if it's just going 50 miles per hour and it doesn't matter which direction it's going, then you would put the absolute value with it when you don't really care which direction it's headed. Okay, go ahead and turn the page to 172. Two vectors are equal only if they have the exact same magnitude and the exact same direction. So if they are going in the same direction, look at A and B, in the same direction, and they have the size of the arrow, you can tell that they have the same magnitude as well. Now look, if they're going in the same direction, look at C and look at D. That's fine, but they don't have the same magnitude. Or in other words, C is going faster than D. D is going slower. And so C does not equal D. Those are unequal vectors. Or if they're the same speed, but going in different directions, those would be unequal vectors. Negative vectors would be the exact same speed, going in the exact opposite direction. Okay, so if one's going one way, one's going the other way, but at the exact same rate, then those would be called negative vectors. And you could say that by the absolute value of G equals the absolute value of negative G. The sum of two or more vectors is called the resultant. Okay, so whenever you add two of them together, it's the result or the resultant. Okay. Go ahead and look at example 1. Let's just jump into it. This is a pretty simple example. Again, this is something that I would think in your physics class you've already covered, and so you should be pretty fine right here. Vector H is 12 pounds of force to the right, and vector M is 15 pounds of force to the right. They're both going in the same direction, which means that we can add them together. When we do, we would get 12 plus 15 is 27. What would we do if they were going in the opposite direction? Well, we would add them together, except one would be negative. And so, for instance, this would be negative 3 pounds, or there'd be a 3-pound difference between the two, plus or minus, depending on which one was going faster or which one had more weight or whatever it is. Okay. All right, example number 2, and this is kind of where we're finally getting back into precalculus right here. And again, you probably had some of this in your physics class, but we'll go ahead and do it again. So if vector n is 11.8 pounds of force to the right, and vector q is 7.0 pounds of force upward, they want you to find the resultant of n plus q. So draw a diagram, use Pythagorean theorem and basic trigonometry. Let's go ahead and jump down over here to my screen, and I will just kind of show you this as we go. So the basic information is here. We're going to put a little dot right here, and this will be like our starting point. So we're starting right here, and then let's do the first vector. We'll take vector n. That is going to be 11.8 going this way. Okay, 11.8. Now, once you get to 11.8, wherever that is, let's say that it's right there at the end of that arrow, then we are going to do the second vector, which is 7 pounds straight up from there, and that's not very straight, but that's straight enough for me, is 7 pounds up, so 7.0. And these are both pounds. Pounds are LB, and I'll put this down here too, LB. So those are both pounds. Okay. Now, here's where it becomes like precalculus or algebra or geometry. When we do this, this is what we're looking for right here. This is the n plus the q. Okay. So we're looking for the hypotenuse. You can use basic trigonometry here because we formed a right angle when we went to the right, and then we went directly up. We formed a right angle. So in order to solve this, you could just use your Pythagorean theorem. Pretty basic right there, pretty simple. We'll just take a squared plus b squared equals c squared. So c squared equals a squared, which will do 11.8 squared, plus b squared, which we'll call 7.0 squared. Plug that into your calculator. You can always, do this if you want to just get c by itself. You could do the plus minus here, but really in precalculus, yes, there's a plus minus in trigonometry because we have negative on the Cartesian plane, but this is real life here, right? So you can't have a negative angle. You can't have a negative, length. So your hypotenuse can't be negative here. So really you only need the positive. So when you do that, you get 13.7, which if you're going to the same amount of significant figures, I would leave it right there. For some reason, the book puts it at 14. I don't see where it asks you to put it into, whole units. So I would put it there, and that would be pounds, right? And now the other question that it wants to know is what is the angle, okay? So what is the angle that's formed here? So we want to know what this angle is. Well, we're going to use basic trigonometry right here. So we don't want to use this one because this one is the one that we found out, right? This was our x. So we don't want to use that because that's a calculated length right there. So let's use, what are we looking at here? Well, we're looking at, so here's the right angle, okay? And so this is going to be the opposite. Okay. So, and this is going to be the adjacent. So we could use tangent since we have opposite and adjacent. So we could go tangent of theta equals opposite 7 over 11.8. And then we would just do inverse tangent to find out what our theta is. So our theta equals, go over here to your calculator, and we're just going to do the inverse tangent of 7, put it in a fraction, 7 over 11.8. And I will close that off, equals, this is a 31 degree angle or a 30.7 degree angle. We'll do 31 degree angle, 31 degree angle. So there's our two answers. Our answer would be that our angle is 31 degrees, and we would have a 13.7 pound direction going. And what would the direction be? The direction would be like a north up right. This one didn't give direction, so it didn't give like north, south, east, west. It gave a right and up. So you could say upward to the right, something like that, or above right is I think how the book says it. Yeah, there you go, above right. So 14 pounds of force, 31 degrees, up and right, or above right. All right, take a look here. It says when the direction of two vectors are oblique. In other words, they're not parallel and they're not perpendicular. Ours happened to be perpendicular. It caused a right angle, so we were able to use Pythagorean's theorem. If it was in the straight line, like the first one that we did, then we just add them together. If it's in the opposite direction, you just add them positive, negative numbers together, and you get the solution. So those are easy, right? Okay, so the first one is just adding and subtracting. That's example 1. The second one is just using Pythagorean theorem and then using our basic trigonometrical functions to get the degree. All right, no problem. Okay. Well, this one's kind of a problem. And I'll tell you why. Because when it's oblique, or in other words, they're going in two different directions, not straight, parallel or perpendicular, we can still find them, but we have to use the law of sines or the law of cosines. Now, this is where more than likely your physics class didn't really get into this. Maybe it did. Maybe you learned law of sines and cosines already outside of, pre-calculus class. You learned it in physics class in order to answer a problem. I don't know. Maybe your physics teacher's already taught you this, so this whole chapter has been a break for you. But if not, if you don't know how to do this, what we'll do here is let's go ahead and turn the page to 173. And we are going to use our law of sines and cosines here to figure out a problem like example number 3, where we're not going in a straight direction. Okay, so let's go ahead and you can stay there on page 173, be looking there. I'm going to switch back over here to my computer so that you can see what's going on here, and as I'm kind of drawing this out as we're solving this together, but you can kind of look back and forth. So, two athletes kick a soccer ball at the same instant, resulting in the following vectors. So, in other words, we have a soccer ball right here, and we have two people kicking it in different directions. Now, this is kind of like a weird thing. Like, you couldn't really kick the same ball in two different directions at the same time. But let's say that one person kicks it, and then you replace the ball, and then another person kicks it, and it goes in two different directions. So here's the first vector. The first vector is 31 pounds of force due north. So let's do this. Let me try to draw a little bit of a straight line here, and I will draw a line 30 pounds due north. Okay, so there we go. The second dude comes in and kicks the ball 45 pounds of force, but he kicks it 30 degrees north of east. Whoa, what is that? Well, let's think about it first. So this is north, right? So this would be south, this would be east, and this would be west. Okay, so north, south, east, and west. And if he kicks it 30 degrees north, let me get my arrow back up here. So if he kicks it 30 degrees north, and it doesn't have to be perfect, okay, just kind of guesstimate 30 degrees north of east, okay, and let's say he kicks it right there, all right? So here we go. We have this first one is what? This first one was 30 pounds. The second one, this purple one, was 45 pounds. Okay. And now, remember, this angle right here is a 90-degree angle, right? But we don't have a right triangle here because this was 30 degrees north of east. So what do we have here? We have complementary angles, right? So we have the whole angle equals 90 degrees. This piece is 30, so what is this missing piece right here? Well, it's a 60-degree angle, right? Okay, so we're at a 60-degree angle. Let me get rid of some of this other stuff right here. This is the important information. All right, so soccer ball was kicked straight north at 30 pounds, and then it was kicked with 45 pounds on a 60-degree angle from the original kick. So that's where we are right now. So this is basically all of our information that we have right here. We've now put it over here into this awesome little drawing. Okay. All right, so now what do you want to do next? Well, what we should do next is kind of look and see, well, what is the question asking us for? Well, if you look in the book, you're going to find that the question says right here, find f1 plus f2. What's f1? This is vector 1, so let's call this one f1. So f1 is the yellow line, and f2 is the purple line. So we want to add these two together. Well, we can't just say, well, I'm just going to add 30 plus 45, and I'm just going to, just put that answer down there, because that's not the way that it works, because, again, we're not going in the same direction. Now, if we were going in the same direction, that would be fine. That would work. No big deal. If we had a right angle, then we would just use Pythagorean's theorem to help us. But we don't. We have an oblique triangle. And you say, no, we don't have a triangle. Yeah, we do. We can connect these, right? So we really do have a triangle right here. So what we want to do is we want to figure this out using the law of cosines. And the reason why we want to use the law of cosines is because look what we have. We have a side, an angle, and a side. So we have a side, angle, side. So when we learned, are we going to use the law of sines or the law of cosines? We learned that when we had side, angle, side, we need to use the law of cosines. So let's jump back into the book real quick and let's take a look at what they do. I don't think I'm going to take the time to do this whole thing because, again, you know how to do the law of cosines. If you don't, then watch the video. I think it was 2 videos ago, or last video, I showed you how to do the law of cosine. So just jump back to that video and watch it again if you're struggling. So what we would do is just plug into it. So you'd take the b squared. So this is a squared, let's just say. Here's your b squared. Here's your c squared minus 2 times, there's your b, times your c, times your cosine of a, which is your theta, which is your angle that you have. What is the angle that you have? Well, the angle that you have is 60 degrees in this case. But we don't need the 60 degrees, all right? We actually need the other one. We need the missing angle because we have the 60 degrees. So we need the 180 minus 60. We need the 120 because this is going to be an obtuse. And so we need the 120. So you'd take the 120. That would be your phi. And then you just plug it in. Okay. And then again, using your calculators, hopefully by this point, you know how to use your calculator well enough. Plug it all in. And then once you get that 65.3, now is when you use the law of sines. Why do you have to use the law of sines? Because now we have enough information to use it, and the output that we need, the resultant that we need. Okay, let's go back here and let's talk about what is the resultant, right? What are we looking for here? Well, what we're looking for is we're looking for this like center right here. We're looking for the resultant, but we're looking to add them up, in other words. So it's almost like what we're trying to do is we're trying to like take this yellow line and like move it in, and we're taking this purple line and moving it in, and then we're joining them, we're adding them. Okay, so you can't just add, you can't just like take the purple line and add it to the yellow line and say, okay, there we go. You have to take the yellow line in and the purple line in, so you have to adjust them, and that's what we're doing. That's the resultant, is this line right here. Okay, so go back over here to your book and let's take a look at this. This is the resultant right here in the middle. I think one thing that I wish they would have done is somewhere write a chart over here, right? Like F1 equals R equals F2 equals, right? Something like that. So basically what we have here from the law of sines is that the sine of A over A equals the sine of phi over the resultant, or the sine of A equals A times the sine of phi over R. That's just moving it to get sine of A by itself. Okay, so once you do that, then you just start solving it. You do the inverse of this right here. You can plug that into your calculator. Here it is. Here's where they finally give it to you. What is the F1? The F1 is this one right here. That's our 30 pounds. Okay, what's our sine of 120? That was our angle that we figured out. Okay, that's our phi. And then our 65.3, what's that? Well, that was our answer. That was our resultant, right? That was our answer from the law of cosines. Okay, plug all that in, and that's going to give us a 23.4 degree angle. So in other words, that is the direction of the resultant is a 30 degree. Okay, so that's the first one, plus the 23.4 degree. And so our direction of our resultant is going to be a 53.4 with 65.3 pounds of force. Okay, and this is going to be our answer. So we have two answers. One comes from the law of cosines, and then you take that answer and you plug it into the law of sines, and it's going to give you your angle. So the angle is 53.4, and the pounds of torque, or the pounds of pressure, force, is going to be 65 pounds would be the way to do that one. Okay. Well, that's all I have for you in this lesson. Hopefully you were able to kind of connect all those things together there. If you missed anything, you can slide it back, take another look there in the book. But just using law of sines, law of cosines, just keep plugging back into those formulas. Make sure that one thing that, again, I think they were a little bit confusing on in the book is I like to just make a chart and say, okay, when I'm using these letters like F and F1 and F2, I like to say what each one of those things are. Okay, so that is the opposite, that is the adjacent, or that is, label what you're dealing with. That's the A, the B, or the C. So if you're labeling everything on your drawing, I think that's going to help you out a lot in order to understand, how to plug them into the formula. But yeah, it's just getting it into the formula and then letting your calculator do the work from there. So basically your job on these is to apply the formula to the question and then hit equals on the calculator, and then it should give you the answer. Okay, if you have any questions, slide it back, watch it again. Hopefully you understood it. We'll see you later. That's all I got for you. Bye-bye.